Hi everyone, this is for Algebra 3, going over the new material for lesson 57. So what lesson 57 is on is more on those sinusoid curves that we learned about a few lessons ago, the sine and the cosine curves. So what you need to know at this point is what a sine and a cosine curve look like. Which ones go through the origin, which ones don't go through the origin. If you don't know that, then I would review that lesson before you actually move on to lesson 57. But in lesson 57, this is where we're going to add in some new variables into our equation of the curve. So this is the two equations that I would put down in your notes. So for the first one, this would be y is equal to a plus or minus b sine c of theta minus d. Now we've already done with a and b. A is where the x-axis is crossing on the y-axis, so at what y value. And then b is your amplitude, so the top minus the middle value. And then c is a new thing, it's called the coefficient. And what this is what a normal curve looks like compared to the curve that you are given. So normally the length of the period is 360 degrees or 2 pi radians. And the way you're going to calculate the length of the period is, so it's 360 divided by your length of the period. Now you can either calculate the length of the period from base to base, from peak to peak, or one full rotation, which would start on the x-axis, circle down, circle up, and end right here. Now, if you start on the negative side, when you're calculating the length of the period, this length would go from 90 degrees, so you would use the absolute value of this degree because it's the distance from 0 to here, which is 90 degrees, and then from here to here, which is 270, so you'd add them together. That's how you calculate the length of the period. So again, you can either go peak to peak, base to base, or one full rotation through, so one period length, which would start at the x-axis, go through, and then end on the x-axis. That would how you would find the length of the period. And so you do 360 divided by or 2 pi divided by, depending on what your period is in. So this one's in degrees. And then D is your phase shift. For D, that would be if they have it in a certain or they have it in a certain format and they want it to be in a different format. So what we're going to look at is number 8. So number 8 says, write the equation the following sinusoid in terms of a sine function, which means that my equation that I'm going to have is going to be, needs to be a sine function. So that would be y is equal to a plus or minus b sine c of theta minus d. Now, if I look at this function right now, if you look at this function, this is actually not a sine function. It's actually a cosine function. So that's where the phase shift is going to come in. The phase shift is going to come in here because in order for this to be a sine function, then this would need to pass through the origin right here. So we're not going to do that yet. I'm going to look at A, B, and C first. So first I'm going to look at A. Where is the x-axis crossing the y-axis? Well, I see that my top is 6 and my bottom is -6. So the midpoint between 6 and -6 is actually going to be 0. So my A is going to be equal to 0. Then I'm going to do my B. B is my top minus my middle. So my top is my 6, and I calculated that my middle is 0. So that would be 6 minus 0. Then step 3 would be to calculate C. Now C is going to be either 360 divided by the length of the period or 2 pi divided by the length of the period. Now this is number 8, and this is in degrees. So I'm going to do 360 degrees divided by the length of the period. Now, again, I told you guys that there's 3 ways to do this. We can either calculate it from peak to peak, base to base, or from the x-axis circling around to the other, back to the x-axis. So I'm going to calculate it from base to base because I see that this is starting at 0 degrees, and then it hits the lowest point again at 360 degrees. So that means the length of the period from here to here is 360 degrees. So my coefficient C is going to be just equal to 1. But then I need to look at the phase shift. I need, in order for this to be a sine function, I need for this to cross through the origin like this. Currently, it's crossing through at 90 degrees. So I need this whole thing to shift back 90 degrees in order for it to pass through the origin like this. So again, currently it's passing through positive 90 degrees. So I need to shift this back 90 degrees so that it becomes a positive sine function. Again, this is currently a negative cosine function. I'm making this into a positive sine function, meaning that my equation is going to be y is equal to a, which is 0. I'm making it a positive sine function, and then I know my b is 6. And then sine c is 1. So because c is 1, I don't need to put it in. And then my phase shift is I'm shifting it back 90 degrees. And this right here would be your answer. So again, you start with a and b the same way as you would before. 360 divided by the length of the period is how you get your coefficient c. So 360 divided by the length of the period. Again, that can be calculated either base to base, peak to peak, or starting at the x-axis and ending at the x-axis as well. And that's how you would calculate the length of the period. Then for the phase shift, we look where it is currently crossing the x-axis, which is at positive 90 degrees. I want it to cross at 0 degrees, which is why I shifted this whole period to the left negative 90 degrees. It needs to shift over 90 degrees in order to pass through at the origin. Now we're going to move on and look at number 9. So number 9, we are asked to write this in terms of a sine function as well. So again, we're going to use the equation y is equal to a plus or minus b sine c of theta minus d. Now, if I look at this function, it already passes through the origin in a positive direction. It slopes up from left to right. So I already know that this is a positive sine function. And that means that there's not going to be a phase shift because it's already passing through 0 degrees. So it already looks like a sine function, so therefore there's no phase shift. Now I'm going to look at my a. Again, where is this crossing the y-axis? Well, my top point is 10 and my bottom point is negative 10, which means that this midpoint between those two values is going to be 0 again. So a is going to be 0. B is my amplitude, the distance between the top and this middle value of 0. So 10 minus 0. Now C is going to be my coefficient. So again, this is in degrees. So I'm going to do 360 divided by the length of the period. So I'm going to calculate the length of the period. Notice how at 0 degrees it's starting on the x-axis. Then it circles up, then circles down, and is ending at 180 degrees. So that means the length of the period is from 0 to 180 degrees. Meaning that you could fit 2 of these curves in a normal curve. And a normal curve would be 360 degrees. Now I know that there's no phase shift because this is already in a sine function. Therefore, I can write up my answer. Again, it's a positive sine function. I don't have an a, so I don't need to put the 0 in, but I know that I have b is 10, sine, and this time my c is 2, and then I don't have a phase shift, so my answer would be y is equal to 10 sine of 2 theta. Okay, and this concludes your lesson 57. So lesson 57 is going to be stamped on Friday of this week. So this lesson will be stamped on Friday. So please make sure you submit that lesson 57 for a stamp on Friday.